Hi, my name is Sandeep Sovani. I'm the Program Director for ADAS and Autonomy at Ansys. At Ansys, we are proud to be the exclusive simulation sponsor of the Indy Autonomous Challenge. As a sponsor, we are providing simulation software, models, and expertise to the Indy Autonomous Challenge. And we are also conducting a series of hackathons. These are fun competitive virtual racing events with training and learning opportunities for the race teams. In May of 2021, we will be conducting a full simulation race where the race teams will be racing virtual models of their autonomous vehicles on a virtual model of the Indianapolis Motor Speedway racetrack inside of a large Ansys simulation. The winners of that simulation race will receive $150,000 in prizes from Ansys. In this video, let me give you an in-depth view of how simulation is being used in the Indy Autonomous Challenge. In this video, we'll talk about how simulation is being used in the Indy Autonomous Challenge. Developing autonomous vehicles is an enormous task. Making sure that the virtual driver of an autonomous vehicle makes the right decisions under all possible scenarios is an enormous engineering challenge. Several studies and reports have estimated that it will take billions of miles of road tests for developing viable autonomous vehicles. That is like making a trip to Pluto and back. Doing all those tests will take hundreds, if not thousands of years. Without a faster method of testing, it will be virtually impossible to develop autonomous vehicles. But fortunately, we have such a faster method. It is simulation. Thousands of simulations can be run simultaneously on the cloud to run millions of test drives every day. Simulation is absolutely essential for developing autonomous vehicles. Simply put, without simulation, we won't see autonomous vehicles in our lifetimes. Because of the importance of simulation in developing autonomous vehicles, early in the development of the Indy Autonomous Challenge, a decision was made to make simulation a prominent part of the competition. The race teams would be provided with simulation software and training, and a simulated race would be conducted prior to the actual track race. In 2019, Ansys joined the Indy Autonomous Challenge as the exclusive simulation sponsor to provide simulation software and training to the race teams and to conduct the simulation race. Ansys has a long history with simulation. Ansys was one of the first engineering simulation software companies launched in the early 1970s. Today, Ansys is the largest engineering simulation software company in the world, with annual revenue of nearly 1.5 billion US dollars and a market cap of nearly $30 billion. Ansys provides a broad set of engineering simulation software tools, ranging from physics solvers to software development toolkits for a wide variety of applications across all engineering disciplines. As the exclusive simulation sponsor of the Indy Autonomous Challenge, Ansys is making three key contributions. First, Ansys is providing simulation software and models to the race teams. Second, Ansys is providing in-depth training and technical support to the race teams on how to use simulation. This is done through a series of 4 hackathons conducted over a span of 9 months. And third, Ansys will be conducting a simulation race in May of 2021, where the race teams will virtually compete against each other in a simulation of autonomous vehicles on a virtual model of the Indianapolis Motor Speedway to win $150,000 in prizes to be awarded by Ansys. Let us look at each of these 3 items in detail. The primary simulation software used in the Indy Autonomous Challenge is Ansys VR Experience Driving Simulator powered by Scanner. Ansys VR Experience Driving Simulator is a full capability autonomous vehicle simulator used to prepare terrain models and driving scenarios and to conduct in-the-loop simulations
including model in the loop, software in the loop, hardware in the loop, and driver in the loop simulations, and to analyze results and generate test reports. Ansys VR Experience Driving Simulator is used to run thousands of simulations to test all possible situations that an autonomous vehicle could encounter in everyday driving. In the Indy Autonomous Challenge, it is crucial for the race teams to test their virtual driver software over thousands of different situations that could happen on the racetrack so that they can program the virtual drivers to navigate safely through all the different situations and perform the best maneuvers to win the race. Along with Ansys VR Experience Driving Simulator, Ansys has provided the race teams with a virtual model of the Indianapolis Motor Speedway oval racetrack on which the actual race will be conducted. The racetrack model replicates important features of the actual track, such as banking angles and pit entry and exit lanes. Textures are added to the road surface and objects surrounding the track for a better visual look. The racetrack model is a standard setup for all simulation-related aspects of the Indy Autonomous Challenge. It is used by the race teams in their everyday simulation work. The hackathon competitions will be held on the same racetrack model, and the final simulation race will be conducted on the same racetrack model. Ansys has also provided the race teams with a virtual model of the race vehicle. The Indy Autonomous Challenge race vehicle is based on a Dallara Indy Lights chassis. Students and faculty members of the Deep Orange program of Clemson University are integrating the powertrain and sensor suite into the Dallara vehicle. The Ansys team works closely with Dallara and Clemson University to create a virtual model that is as similar as possible to the actual vehicle specifications. Physics of vehicle dynamics is included in detail in the Ansys virtual vehicle models. The sensor suite is replicated closely as well. And finally, a graphics designer models the visual look and feel of the vehicle based on the real vehicle's design. In addition to the driving simulator software, Ansys is providing Ansys CAD Suite to the race teams. Ansys CAD Suite is a model-based development environment for creating embedded control software. Ansys CAD Suite can be coupled with the Ansys VR Experience Driving Simulator powered by Scanner to run simulations and develop control systems of autonomous vehicles. Ansys CAD has been used for safety-critical systems such as aircraft, flight and engine controls, automatic pilots, automated trains, and nuclear power plant controls. Safety is of paramount concern for autonomous vehicles, and particularly so in the Indy Autonomous Challenge, where autonomous vehicles will be racing each other in close proximity at speeds in excess of 200 kilometers per hour. Therefore, it is essential to employ time-tested, safety-critical embedded software development practices and tools such as Ansys CAD Suite in the development of the virtual driver software in autonomous vehicles. Microsoft is a co-sponsor of the Indy Autonomous Challenge and is providing resources on the Microsoft Azure cloud to the race teams for conducting simulations. Microsoft's Azure Lab Services offering is ideal for deploying software on Azure for a large number of participants, such as the students participating in the Indy Autonomous Challenge race teams. Ansys has deployed the Ansys VR Experience Driving Simulator software on Microsoft Azure virtual machines with graphical processing units, GPUs, that are essential for computing sensor inputs. Additionally, Linux-based virtual machines are provided to the race teams that are similar to the actual computer on the real race vehicle on which the virtual driver software will run during the actual track race. A connection is established between the simulator running on the Windows GPU virtual machines and the Linux virtual machines on which the virtual driver software runs via RTI's Connect software based on the industry standard data distribution service protocol. Each race team's virtual driver software controls its assigned virtual vehicle in the simulator. This deployment via Microsoft Azure has proven to be particularly useful during the COVID-19 pandemic. Students from the Indy Autonomous Challenge race teams can quickly log into their assigned virtual machines anytime they want, 24 hours a day, 7 days a week, and perform their simulation activities effectively. The Microsoft Azure cloud has been quite a boon for the Indy Autonomous Challenge during these COVID-19 pandemic times, as it has made it possible to continue preparations for the challenge without interruption. In addition to providing simulation software and models, Ansys is conducting an extensive year-long training program for the race teams that is helping the students develop deep expertise in conducting autonomous vehicle simulations. The training program is comprised of a series of 4 hackathons, along with support forums and regular town hall meetings with the race teams. The hackathons are fun competitive events in which the race teams first receive formal classroom training on various aspects of simulation and are then provided with some race challenges. Teams conduct simulations of the race challenges and submit their work to Ansys. Ansys then analyzes the team's work and holds a fun mini race event where the teams see how they performed in the challenges as compared to the other teams. The winners are then awarded prizes at the end of each hackathon. In the latest hackathon completed, the teams were given 2 challenges. The first challenge was fastest lap, in which each race team had to drive their vehicle for 1 lap around a virtual model of the Indianapolis Motor Speedway in the least possible time. Here you see a video of the winning team's simulation, whose virtual driver closely followed the inner boundary of the racetrack to victory. The second challenge was late braking, in which a team's virtual driver had to safely overtake 2 computer-generated drivers who were tasked to obstruct the virtual driver. Hackathon 2 was a close contest, with the winner winning by fractions of a second. The Italian team Polymove from the Technical University of Milan, Politecnico di Milano, took the championship for Hackathon 2, and the second and the third prizes were taken by University of Alabama and Auburn University, respectively. The next hackathon in the series, Hackathon number 3, will be conducted in January 2021, followed by Hackathon number 4 in February of 2021. In Hackathon 3, there will be 2 race vehicles on the racetrack piloted by virtual drivers of 2 separate teams. Their mission will be to outmaneuver each other in a high-speed race of 5 laps around the Indianapolis Motor Speedway oval. In Hackathon number 4 in February, the stakes will rise with 4 vehicles on the track at the same time, piloted by 4 virtual drivers of 4 different race teams. In the Indy Autonomous Challenge, the race team's simulation work will culminate in a simulation race that will be conducted by Ansys in May of 2021. The simulation race will be conducted on a virtual model of the Indianapolis Motor Speedway inside the Ansys VR Experience Driving Simulator powered by Scanner. The simulation race will be comprised of a number of heats. In each heat, 8 race vehicles piloted by virtual drivers created by 8 different race teams will try to outmaneuver each other in a 20-lap race. Teams will be put in brackets, and a number of heats will be conducted to pick the participants of the final heat. The first place winner of the final heat will receive a $100,000 cash prize from Ansys, and the second place winner will receive a $50,000 prize. After receiving in-depth year-long training in simulation and developing and training their virtual driver in simulation, the teams will transition to the actual track race phase of the Indy Autonomous Challenge. The teams will receive keys to the actual race vehicles and will transfer their virtual driver software from Microsoft Azure Cloud to the actual computer on the race vehicle. It will be akin to a student graduating out of university into the real world. With all the training received in simulation, the virtual drivers will be off to a running start in the real track race.